You type a name and hit enter. But no cable, no router, no server anywhere knows what stewmore.dev means. The network only moves packets between numbers. Before your browser can ask for a single byte, it has to find out where that name lives. That lookup is DNS, and it's the first trip your request ever takes. DNS is the internet's phone book, but nobody owns the whole book. The answer to where does this name live is spread across a hierarchy, and the job is to walk it once, then remember. Understand that walk, and you understand why the web feels instant the second time, and why, when things break, it's always DNS. Here's the foundation. Every server on the internet sits at an IP address, a number. Routers move packets between numbers. They have never heard of your domain. The name you typed is for you, and before any connection opens, it has to become a number. Your browser doesn't rush onto the network. It checks its own DNS cache first. Miss? It asks the operating system, which has its own cache and a little file called hosts that can override everything. If any rung of that ladder has the answer, the lookup is over in microseconds, without a single packet sent. When the ladder comes up empty, your machine hands the question to a recursive resolver, usually run by your ISP, or a public one like 1.1.1.1. Recursive means it takes full responsibility. It chases the answer across as many servers as it takes and hands you back just the result. And because it serves thousands of people, it has probably already asked your question today. Now the beautiful part. The resolver reads the name backwards. It asks a root server, which doesn't know your site, but knows who runs .dev. The TLD server doesn't know the address either, but knows which name servers are authoritative for the domain. 3 referrals, each narrowing the world, until the one server that actually holds the answer speaks. And what lives at that server isn't one number, it's a set of records. An A record maps the name to an address, quad A, for IP version 6. A C name says this name is an alias for that one. MX records route the domain's email. TXT records prove ownership. Your browser asked one precise question: give me the A record. Every answer comes stamped with a time to live, a number of seconds. That's its shelf life. Browser, system, resolver may keep it exactly that long, and not a second more. When the clock runs out, the entry dies, and the next lookup does the walk again. Set it long, and you're fast, but slow to change. Set it short, and you're fresh, but chatty. A walk across the planet sounds slow, so why is DNS fast? 2 tricks. Anycast. The 13 root addresses are announced from hundreds of locations, and the network simply routes you to the nearest copy. Same address, different building. And everything we've seen, caches. In practice, the resolver almost never starts from the root. The whole hierarchy is warm. Now you can decode the classic outage. Change a DNS record, and nothing updates the world. Every cache just keeps serving the old answer until its own TTL expires. For a while, half the internet sees the new address, and half sees the old one. That's what waiting for DNS to propagate really means. And it's why, when a site half works, engineers sigh. It's always DNS. So here's the whole model in one breath. Names are for humans, the network routes numbers. Your browser climbs its cache ladder. A resolver walks the hierarchy. Root, TLD, authoritative. And the answer rides home stamped with a TTL, cached at every stop. Ask once, cache everywhere. That's why the second visit is instant. But notice what your browser just did. It trusted an answer about where to go. An address tells you where the server is, not that it's really them. Anyone can answer to a number. Proving the identity, the certificate, the handshake, the padlock, that's TLS. And it's where we go next.